Hello everyone. We are solving past paper questions of AS Physics and we are doing it topic wise. This is our third topic, that is electric circuits. The question is, a circuit consists of three identical 1.5 volt bulbs connected to two 1.5 volt cells. The switch is closed. Which row describes the change in brightness of bulb Y and bulb Z? So the question is that if we close this switch right here, how will the brightness of bulb Y and bulb Z change, right? Now, this is a really good question because it gives you a really good understanding of how parallel circuits work. So make sure you understand this question um, all the way to the end because it will help you understand a lot of things about parallel circuits. The first thing that you should know about parallel circuits is that, let's say if I have three resistors, R1, R2, and R3, and they are in parallel. So let's say like this. Let's also name them R1, R2, R3. You should always remember that the equivalent resistance of this parallel circuit are equivalent. It will always be smaller than R1 or R2 or R3. So the equivalent resistance of the parallel circuit will always be smaller than the smallest resistance in the circuit. Let's say if R1 is 2, R2 is 4, R3 is, let's say, 8. So you should know that the equivalent resistance will be smaller than the smallest resistance connected in this circuit, that is 2. So in this case, R equivalent will be smaller than 2. So if you understand this concept, you will see that when we close the switch, before closing the switch, we had only one resistor here and one resistor here in the circuit, right? But after we close the switch, now we have a parallel combination in this part, that is X and Y, right? So if I ask you, how will the total resistance between this point A and this point B, how will the total resistance change after I close this switch? The total resistance, like I just explained here, the total resistance will decrease, right? Between point A and point B after closing the switch. Because the total resistance will go down, that tells you that the total voltage drop between A and B will also decrease. So after closing the switch, if the total voltage between A and B goes down, that means that the brightness of bulb Y should also decrease, right? Now, all of this argument, it eliminates option A and option B. It cannot be option A or option B because both of these say that Y should be brighter after closing the switch. We just discussed that it should be dimmer or brighter. So it's either C or D. Now to choose between C and D, we have to look at what will happen across the resistor Z, right? So from Kirchhoff voltage rule, we know that if the voltage of this cell is 12 volts, all of this 12 volt must drop across the circuit, right? So if, for example, 6 volts is dropping between A and B, if VAB is 6 volts, the rest of the 6 volts out of these 12 volts will drop across the resistor Z, right? Now, after closing the switch, like I said, the voltage drop between A and B will decrease. That tells you that the voltage across Z should increase by the same amount, right? Because the sum of these two has to be equal to 12. So let's say if voltage AB decreases from 6 to 4, that means that the voltage of a voltage across Z will increase by 2 units. So it was 6, now it will become 8, and the sum of these two, 8 plus 4, which is 12, will satisfy the second law, second Kirchhoff rule, right? Because Kirchhoff's second rule says that sum of all the voltage rises plus voltage drops in a closed circuit must be zero, right? So 12 volts here, this is, let's say, plus 12 volts if we are crossing the cell in this direction. So these 12 volts must drop before reaching this point if we go around the circuit. So that means that voltage across Z is increasing. That means that the brightness of Z will also increase. So that means that the correct option is option C.